Okay, for number one, we're trying to see if this function satisfies the hypothesis of the mean value theorem. So, in order for that to happen, it has to be continuous. Since this is a parabola, we know that it's going to be continuous. There's no holes, no jumps, no asymptotes. It also has to be differentiable. So no sharp turns, no vertical tangent lines. We know that's true for these for any type of a parabola. So now we're trying to figure out at what point in between x equals 1 and x equals 5 will the derivative equal the slope between the endpoints. So this is the instantaneous rate of change, and this is the average rate of change, the slope between the endpoints, or the slope of the secant line. So this is the formula we're using. First, we need to find the derivative of f of x. So in this case, our derivative is 6x plus 1. And that needs to be equal to f of b minus f of a all over b minus a. So in this case, that's going to be f of 5 minus f of 1 all over 5 minus 1. So f of 5, we're just figuring out what do we get when we put 5 into this function, right? Just basic function notation. So f of 5 equals 3 times 5 squared plus 5 minus 4. So we get 75 plus 5 minus 4, which is 76, minus f of 1. So if we put 1 into that function, 3 times 1 squared plus 1 minus 4, that gives us 3 plus 1 minus 4, which is 0. So now we're just trying to solve for x. We're trying to find that point in between 1 and 5 where the instantaneous rate of change equals the average rate of change. So 6x plus 1 has to equal 19. Subtract 1 from both sides. Divide both sides by 6, and x equals 3. You need to make sure that your answer here ends up being in between your endpoints here. If we got x equals 7, that's not going to be a solution because it has to be between these two endpoints.